This video is an additional video if you needed some help with the problems that we went over in Introduction to Exponential Functions Part 2 and 3. At the end of Part 2, we presented these three problems, and then in Part 3 we went over the answers, and that was identify each of these functions as either exponential growth or decay, identify the starting value of each, and identify the growth or decay rate of each. And what we're going to look at is we're going to look at functions of the form y is equal to ab to dx, or functions in the form y is equal to a 1 plus r to the x. These are actually exactly the same. The only difference is we've taken the b and rewritten it as 1 plus r. It doesn't matter. This way, in a lot of ways, is easier to understand in the problems that we're doing. But let's work with this one first. Well, the first question we want to know is whether it is exponential growth or decay. And there's a simple rule using this formula. And the rule is simply this. If b, the base, right, the number that you're raising to the power, if it's greater than 1, then we call that an exponential growth function. And if that number is between 0 and 1, we call it an exponential decay function. And in the next video, we actually start graphing these functions, so it'll be more obvious why we call them exponential growth and decay. So let's look at each of our three problems and see if they're exponential growth or decay. So I've marked in pink here the base of each one. The base here is 1.43. So you simply ask yourself, you go, self, is that number bigger or less than 1? In this case, the number is greater than 1. So if it's greater than 1, then it's an exponential growth function. So this one is exponential growth. This one is 0.96. You ask if that's greater than or less than 1. So that is less than 1. So therefore we know that that's exponential decay. And this one, 5/3. 5/3 is greater than 1. So we know that's exponential growth. That's all you do for the first step. You simply say, identify b and see if it's greater or less than 1. The next step is simply finding the starting value, and a is the starting value. And if it appears like there's no a at all, then that means a is just 1. So let's look at each one of these. Let's mark in blue a. So in this one, this is a, and this one, this is a, and this is a. So this one, the starting value is 109. And in this one, the starting value is 80. And in this one, the starting value is 12. That's how you identify the starting value. Now the growth rate is a little bit trickier, and there's actually, you can call it a growth rate or a decay rate, depending on whether it goes up or down. So the way you find the growth rate, it's actually easier now to start with this one, but you can work with this one as well. So here, the growth rate is defined as b minus 1. In this one here, a 1 plus r to the x, the growth rate is simply r. And I actually like working with this form a little bit better, so let's work with that form. So in each one of these, let's do it in turn. The first one was y is equal to 109, 1.43 raised to the x. Let's rewrite that. That's y is equal to a 1 plus r to the x. So as we just saw, a is 109. So here we have 1 plus r is equal to 1.43. And r is the growth rate, so I'm going to subtract 1 here and subtract 1 here, and you get r is 0.43. And that's your answer. We say the growth rate is 0.43. Oftentimes the growth rate is in percentage terms. So we can either say the growth rate is 0.43 or the growth rate is 43%, either way. And that's all you do. In the second one, f of x is 80, 0.96 to the x. Here you have 1 plus r is 0.96. So again, you subtract 1 from each, and you have r is equal to minus 0.04. So that's the growth rate. We say the growth rate is minus 0.04, or you can put it in percentage terms, minus 4%. Now some people, instead of talking about growth rates, talk about decay rates, and that's fine. If something grows at a negative rate, that's the same thing as saying that it decays. So to do the decay rate, you simply switch the sign. So here we say the decay rate is 0.04 or 4%. Be careful, don't say the decay rate's negative, because that would be incorrect. Here the growth rate's negative or the decay rate is positive. And the last step, the last problem, y is equal to 12, 5/3 to the x. Here you have 1 plus r is equal to 5/3. You want to find r, so you subtract 1 from both sides. Now, whenever I do fractions, I like to do fractions on the sides. That's 5/3 minus 1. Put that over a common denominator. The common denominator, this is 1 over 1. The common denominator is 3. So that's 5/3 minus 3/3, or 2/3. So we say r is 2/3. Now, normally in math, we like fractions. This is one of the few exceptions. We actually like decimals better. So you just use your calculator to find out in the decimal, and that's pretty straightforward. To find 2/3 as a decimal, you simply go 2 divided by 3, and you get 0.66 repeating. Round up, you get 0.67. So you say a growth rate of 0.67 or 67%. And that's working out the 3 problems that we did last time. In the next video, we'll start graphing them.